Hi to all. In this video, I'm going to explain about cogging and crawling of induction motors. These two are very dangerous for the induction motors. It should not be. It should be avoided to work the induction motor in safe zone. Okay. Now we see cogging and crawling of induction motor. The important characteristics normally shown by squirrel cage induction motors are crawling and cogging. These characteristics are the results of improper functioning of motor. Okay, the motor should be run in proper way. Okay, if these two are occur in that machine, the machine will not be work in proper way. Okay, so the characteristics are results of improper functioning of motor. That means either motor is running at very low speed or it's not taking the load. Okay, when crawling occurs or cogging occurs, the motor becomes very slow and sometimes it will not take the load. That means it goes to stop. Okay, now see crawling of induction motor. Sometimes the squirrel cage induction motors exhibits a tendency of run at very low speeds, as low as 1/7 of the synchronous speed. This phenomena is called crawling or rolling. Okay, of an induction motor. Suppose if it is run at 1500 or let us consider 700 rpm. Okay, if crawling occurs in that machine, it becomes 100 rpm. Okay, 1/7 of its synchronous speed. Okay, this action is due to fact that flux wave produced by stator winding is not purely sine wave. Okay, if the flux produced in the stator is not a pure sine wave, then this type of problem occurs. To avoid that, we should make the winding of stator winding should be in proper way. Okay, if it is a complex wave consisting of a fundamental wave and odd harmonics like third harmonic, fifth harmonic, seventh harmonic, etc. Okay. The fundamental wave revolving synchronously at synchronous speed ns. Okay, that is let us consider it's a 700 rpm means 700 rpm, that fundamental wave. The fifth and seventh harmonics, the third, whereas third, fifth, and seventh harmonics may rotate in forward or backward direction at ns by 3, 700 by 3, 700 by 5, and 700 by 7 speeds respectively. Hence, harmonic torque are also developed in addition with fundamental torque. Okay, there are four torques will be occur if we are not going for a proper sine wave generation in stator. It becomes a third harmonic, fifth harmonic, and seventh harmonics also generated in that stator waves. So when it is goes to seventh harmonic, 1/7 of the speed it occurs. That is 700 by 1/7. It becomes 10 rpm. 10 sorry 100 rpm and 700 by 5 around 125 or 150 rpm like that. Okay, third harmonics are absent in balanced three-phase system. Okay, the third harmonic will be absent. Hence, third harmonic do not produce rotating field and torque. Okay, the total motor torque now consists of three components. One is basic component, basic or fundamental torque with synchronous speed ns, fifth harmonic torque with synchronous speed ns by 5, and seventh harmonic uh, called torque with synchronous speed ns by 7, provided that higher harmonics are neglected. Okay, now the fifth harmonic current will have phase difference of 5 into 120, that is 600 degree. So 2 into 360 minus 120, 120 degree. Hence the revolving speed setup will reverse the direction with ns by 5. A small amount of fifth harmonic torque produces braking action and can be neglected. Okay, because if it is the motor runs in clockwise direction, the fifth harmonic which will be generated in anti-clockwise direction, but its amount will be very small. Because of that, it will not be affected. The seventh harmonic current will have phase difference of 7 into 120, that is equal to 840. 2 into 360 plus 120. So 7 into 120 is equal to 840 degree. That 2 into 360 plus 120. So one more 120 degree will be generated here also. Okay. In the case of fifth harmonic, minus 120 degree will occur. In the case of seventh harmonic, plus 120 will occur. So hence there will be a setup rotating field in forward direction, but in the fifth harmonic it produces in reverse direction. Here seventh harmonic will produce in forward direction with synchronous speed equal to ns by 7. If we neglect all the higher harmonics, the resultant torque will be equal to sum of fundamental torque and seventh harmonic torque. The seventh harmonic torque reaches its maximum positive value just before 1 by 7th of the ns. If the mechanical load on the shaft involves constant load torque, the torque developed by the motor may fall below this load torque. In this case, motor will not accelerate up to its normal speed. Only it goes to 1 by 7th, but it will run at the speed which is nearly 1 by 7th of its normal speed as shown in the figure. This phenomena is called crawling of induction motor. These are the phenomena of crawling of induction motor. To overcome that, using soft starting method for producing a pure sine wave, good design for the starter winding to reduce harmonics. Okay, these are the two ways to avoid the crawling of induction motor. And this is the thing, this is the crawling. Okay, this is a stable state and this is the crawling, and it becomes unstable, and here again it becomes stable. Okay, let's see the cogging. Cogging or magnetic locking or teeth locking of induction motors. Sometimes the rotor of squirrel cage induction motor refuses to start at all, particularly if the supply voltage is low. This happens especially when the number of rotor teeth is equal to number of stator teeth. Because of magnetic locking between stator teeth and rotor teeth, when the rotor teeth and stator teeth face each other, the reluctance of the magnetic path is minimum. That is why the rotor tends to remain fixed. This phenomenon is called cogging. Cogging is nothing but locking, magnetic locking between stator and rotor, or magnetic locking of the induction motor. Method of overcoming cogging. This problem can be easily solved by adopting several measures. These solutions are follow. The number of slots in the rotor should not be equal to number of slots in the stator. Okay, S R should not be equal to S S. Okay, skewing of the rotor slots, that means a stack of the rotor is arranged in such a way that it angled with the axis of the rotation. This also used to avoid the cogging. Thank you.